Hello everyone and welcome to the next session of our Digital WE Days. My name is Markus Eberle and I will moderate this webinar today. So welcome to this session with the topic Rethinking Power Connectors, how WE REDFIT Crimp saves time and money. I'm very happy to welcome the man next to me, Götz Schattmann. Hello. Hi.
Hi Markus, hope you're fine.
Yeah, I'm doing good so far. So, Götz is a field application engineer in our company for the topic of electronic interconnect and electromechanical solutions. Yeah, he will introduce you into the topic today, which is about tool-free, solder-free and mechanically stable SKEDD connectors redefine PCB connectivity. But how do they save time and boost reliability? Let's have a closer look.
Yeah, hello to everyone who's here with us today. My name is Götz Schattmann and I'm a field application engineer at Würth Elektronik, and I'm responsible for the electromechanical components. Well, rethinking power connectors. The most important requirements for this new connector concept here was the ease of use, absolute and proven reliability that can be used in a maximum of different applications. And so I'm very glad that today we introduced the all-new REDFIT Crimp WR-WSP connector, which is a tongue breaker, honestly. So let's call it the REDFIT Crimp. And this is based on our SKEDD technology. So a little agenda, and we'll have a quick intro, and then we'll look a little bit deeper. What is the REDFIT Crimp? We check out some details, how we did the qualification, and in what kind of application you can use it. So I think everything was explained pretty much in less than 30 seconds. Okay, any questions? No, of course. We will take a closer look inside here. So what is the REDFIT Crimp? We saw it's a pluggable connector. It's solderless because it's directly connecting into the PCB. Therefore, we don't need any tools, and electrical performance is also pretty good, like it's covering the amperage of 16 amps at maximum voltage of 400 volts AC. So you can also use it in 3 grid systems. And we offer number of poles from 1 to 5. We come with a pitch of 6 millimeters from pin to pin. And you saw also in the video the reverse polarity protection. Then we have active locking, and it's available in 5 different colors. And by the way, it's compliant to UL and VDE, and of course in terms of flammability, UL 94V0, and we have the glow wire conformity, which is relevant also for unattended appliances like household appliances and so on. So if you look into some details, it's very easy to plug and unplug. You can put it directly into the PCB. That means you don't need to have a socket installed on the PCB, because the vias in the PCB, they are the socket. So therefore, no soldering is required. If you plug it in and then just push down the frame, and then it's locked and it's very stable, and it's approved up to 10G. So here we see it from the bottom side of the PCB, how the locking system works. You see the, let's turn on the laser pointer. You see the red angles here, like these are hooks that spread when the frame is pushed. So this locking mechanism is spread outside and is locking the complete contact. Yeah? And here you see the electrical contact. Of course, we have two, one on each side, yeah? And therefore we can guarantee a good electrical conductivity as well. The reverse polarity protection, you see here, there's a separate pin. This is its position is very unsymmetric, so this secures that you cannot plug in this kind of plug in a different way, not even from underneath. So this is the protection against this. Then if you look on the contacts itself, it's the patented SKEDD technology contacts. And yeah, on the upper side here, we have the crimp place where the wire crimp can be placed. Afterwards, it looks like this. So we can achieve a gas-tight, almost gas-tight connection here. And it's suitable for cables from 18 to 16 AWG, or also when it comes to square millimeters, it's from 0.75 up to 1.5 square millimeters. The material is a special copper alloy, and it comes with a silver plating right on the contact front here, but it's tinned behind here in the crimp area. We also offer pre-crimped cables. They look a little bit like this, where a cable is attached already, so you can use it without any tools for your development. A hand tool, of course, is available, and you also get, or can you buy the terminals on reels if you need it for the automated processing in serial production. Here we see a graph about the A module. A module means about the flexibility of the copper alloy. And this is securing us a reliable contact force and therefore a low resistance. And as we all know, a low resistance under current means that we have a low heat development. Here we're also naming the mating cycles. It's specified for up to 10 mating cycles. In many systems, these connectors would be connected only a single time, or maybe if there is a case that you need to repair it. But in other cases, more mating cycles would be wanted. Now here we need to specify what is the meaning of these 10 mating cycles. The meaning here is that even after all mating cycles have been done, we still guarantee that the specifications given on the data sheets will be met. So it's not broken at the 11th attempt or at the 12th one. That does not mean it's not working anymore. Yeah? It's only the specification we meet within the 10 mating cycles. Now here about the PCB footprint. You see the PCB. It's designed for a PCB thickness of about 1.6 millimeters, which is very common, very standard, like 1.55 or up to 1.6 millimeters. And the pitch means the distance from center to center here is about 6 millimeters. And it's very important that you respect the tolerance for the opening here. The tolerance is given with 0.05 millimeters for the via, so the end hole should not be bigger than 3.55 millimeters, as we can see here. If it's too big, then of course the contact force cannot be reached anymore, and if it's too tight, then maybe the contact gets deformed when entering. About the via plating, you're fine with almost every kind of plating on the market, like incl, which means chemical gold. Then we have hull for tint surface, also chemical tin. OSD has not been tested so far. Yeah? Should work also fine. Also want to mention that the restring, you see the copper here around of the via. Normally there is no restring required for this kind of connector, but the PCB manufacturer cannot produce it without a restring. So minimum restring of about 0.1 up to 0.25 millimeters is fine. Still fine to reach the distance to meet the creepage and clearance distances for all the different standards like UL and IEC. So if you want to see how it works, here's a schematic of the contact. You see the angles right and left. These are made to hold the contact in place, and the contact where the current flows to the via is right in this area and here. So this is the point where we connect to the PCB. Also, we want to take a look on the D rating, which is really important for any kind of connectors, not especially this one, but every connector has its own curve. And we see that the REDFIT Crimp offers a temperature range to be used in from -25 up to 105 degrees. Yeah, this is important to offer good thermal and electrical resilience. And if we go to the scale here, it's no matter if it's a 1-pole, 3-pole, or 5-pole, or anything in between. Looking at the cable size, like the AWG16, for example, which is listed up here, and we see the amperage here on the vertical side, and the temperature is given on the bottom line. So within a range of almost 60 to 65 degrees, you can run the full load with this contact. And only after that, you have to reduce the current not to overheat it. So you always want to stay in the safe area, like here or like here, and never go to the right side of the line, because this is done over temperature. So, by the way, we also have a nice seminar about the D rating of connectors, if you want to learn more about this. And one tip in general is if you use bigger wires or bigger traces, then you can achieve better cooling. So this will draw the thermal energy away from the contact. Now, about the qualification, it was important for us, as I mentioned, that we want to achieve a very reliable system. And therefore, we have a full reliability test available. And it was taken by following to the industrial criteria like the IEC 6512 and IEC 668, which really describes how to measure such a system. Also in terms of mechanical force, the dynamic force, I mentioned already, it's stable up to 10 G, while we tested up to 20 G, and there was no microcut seen at that speed as well. Also UL and VDE and also IC is important to be compliant, that you can use it in any kind of application. Then from the flammability, I already said that we met the V0 standard in terms of UL, and glow wire up to 950 degrees conformity. Then the plastic is totally halogen free. The contacts itself are fully lead free, not using any exemption in the rule, but it's completely lead free. And therefore we reach the ROS and REACH standard, as you can see here by these signs. And by the way, the whole connector is designed, developed, and made in Germany. So about the application, it's up to you, I think, yeah. But here you have some examples when it comes to bring power to the PCB, also mains power. Here it covers up to 400 volts AC, also in three-phase systems, and yeah, it would be very good working as a motor connector or a connector for all kind of drives. Then also PCBs and control cabinets to attach them with power. And also as a connection for option boards. If you have a master board and you want to have some option boards that you occasionally install or not, then you have a good possibility without installing a board connector that you may use or not, but you can just attach via the direct RedFit Crimp plug. Then also you can use it as a flexible board-to-board connection whenever you need to bring power to a different point or to a different PCB. Yeah, and you see the four dots here. That means it's up to you how you want to use it. Yeah, and what we can see is that we can pretty good use it as an alternative for flat taps, for example, well known in the market as fast on. And whoever tried to unplug a fast on and replug it again, maybe you discovered that this will not have the same strength anymore. Yeah? So very difficult here. In terms of terminal blocks, you can replace them. Again, you don't need a socket on your PCB anymore. And also any kind of two-part wire-to-board connectors like this system, and so on. The list is not full here. So now I switched to the second camera here. You can see the different connectors here from one pole, which is here, up to 2, 3, 4, and 5. And here we have a little demo board. I can show you. This is the footprint as given in the drawing, but it's in red, of course. And here you see this is the connector, and with the connector we have here the polarity pin. With this polarity pin, this of course has to go inside of the PCB. This is the frame, the locking frame. Now it's open, and I want to insert it into the PCB like this. Now it's in, and I push down the frame, and you have a clear click sound. And you can see it's attached here. Everything is coming through. It's only the 4-pole version, and now it's holding really, really hard. It's so easy to use, and if you want to unplug, just lift the frame again, and then you can unplug it. Very easy to use. So now it's up to you. Ask for your samples today, and thank you for listening.
First of all, Götz, thank you very much for your presentation. It's interesting to see the connectors and how they work. Before we start into the questions, I will also share the handout, so you should be able then to download it also from your side, so it should be now available. Okay, then we have some time left. Let's dive in. So first question we can see, or let me just... Okay, here was the first question. While it can only be fully connected one way, is it actually prevented from momentary reverse polarity contact if incorrect insertion was attempted?
So let me check the question again. Is actually prevented from momentary. Yes, because if you look to the connector, maybe we can switch to the camera. There is no contact visible on the outside. So if you try, without locking, you try to use it from underneath, you cannot connect, you cannot fail to connect it like this. Yeah. Therefore, the answer is yes.
Okay, good, thank you very much. Then let's go on with the next question. Is the current or the temperature derating curve for one pole or for a number of poles at maximum current at the same time? And next question, how many poles with how much current each pole?
So full current, full 16 ampere on every pole is possible, and therefore, there is no limitation or no differentiation between 1 up to 5 poles. And the specifications all the same, so you can use it with a 5 pole.
Okay, thank you very much. Then the next question, how much setup time can I actually save with these connectors?
Okay, that's up to you. How? Okay, at least if you compare it to other crimping solutions, then you will be about the same, but you don't have to have a connector on the PCB. So the setup time for the cabled connector is about the same, but you just don't need a connector on the PCB.
Okay. Then let's go on with the next question. Is the proposed connector once plugged on the PCB retain the male connector, or is it a male and female connector in one and the entire assembly would come off the board?
Let me read this question again to understand it right. Plugged on the retain male connector. Is it a male, female connector? Simply would come off the board. There is one image, maybe we can go back, which might explain it a little bit better. So if you look to this side of the connector, so the angles outside, these kind of wings, they're only to hold the connector in place. And then we have the real connector where the electrical connection is made here against the via on both sides, while this kind of plastic is there to spread the contacts against the side walls. So the side walls here in the via, this is the female, so to say, and the contact here is the male part. This describes it.
Okay, thank you, Götz. Then the next question is a little bit shorter. Is it available in right angle cable entry?
Not yet, but you can easily bend it on top. Of course, it's getting a little bit, maybe you can switch you can easily bend it on the top. Yeah, and a right-angled version, maybe this will appear. Now we start with this product, and yeah, we'll see.
Okay. Then the next question, will this help reduce errors or rework in our assembly process? Hopefully.
Yeah, that's a basic idea. So you have to compare what kind of connector you can replace. If you talk about a screwed connector, then of course you have to do all the manual work with screwing each separate cable. So here the mating and unmating is done really fast. And of course, every contact is in its final position. So you cannot change wires.
Okay. Yeah, the next question is on German. Maybe we can answer it as well. So I think it's about the thicknesses of the tin and what silver?
Tin and the silver surface is about 6 microns.
Okay. Perfect. Thank you, Götz. Do you plan smaller versions with lower current rating, for example, 5 amps?
Maybe you've seen our SKEDD connector called WR-WSP, and I show it here. We already have this in place. This is based on IDC connector. Inside this kind of connector coming from 4 poles up to 20 poles, and it's using the same technology like the SKEDD. And as you can see here, we have the footprint in the PCB, and we can easily plug it in here to make the connection and to unmate it as well. So this is already in place. If you're asking about something in between, I have no idea. We will see how it works with this kind, and if it's relevant or necessary, then of course we can do a smaller one as well.
Okay, so then we go on with the last question I think I see so far. Does WE supply an applicator for it? And if, high volume?
If you talk about applicator, then I suppose you mean the cable connector for the crimps. We don't have an applicator for ourselves, or we don't sell it ourselves, but we have a connection to a lot of harness makers and tool makers that can easily, normally your local tool maker in your area can adapt this kind of crimp easily. On the other hand, we also have some reference addresses that we can provide to you.
Okay. So then I think we are already at the end of our session.
And we're right in time.
Yeah, Götz, thank you very much for all the information. Thank you for your attention. And yeah, now you can also see the link to the digital WE days. We also have some more sessions coming up related to power connectors. So yeah, stay tuned. There is a lot of information to get. And thank you for your attention.
Thanks for being here.
Bye-bye.
Bye.